How do celestial mechanics affect telescope mount alignment? Imagine trying to follow a moving target with a camera that can only point straight ahead. That's similar to what telescopes do when tracking stars across the sky. Celestial mechanics, or how objects in space move under gravity, play a big role in how we align our telescope mounts. When Earth spins on its axis once every 24 hours, stars appear to move from east to west across the sky. To keep a telescope fixed on a star, the mount must move in sync with this apparent motion. That's why many telescopes use an equatorial mount, which has one axis called the polar axis aligned parallel to Earth's rotational axis. When this polar axis is correctly aligned with the celestial pole, the telescope can follow stars smoothly by turning just this one axis. Aligning the mount involves a process called polar alignment. In the northern hemisphere, the goal is to point the polar axis toward Polaris, the North Star. Polaris is close to the true north celestial pole but not exactly on it, so for casual viewing, pointing at Polaris works fine. For more precise work, especially astrophotography, you need to fine-tune the mount by adjusting its azimuth and altitude until the star's drift is minimized. This drift alignment involves observing how a star moves over time and making small adjustments until the star stays centered. Some use a polar scope, a tiny telescope built into the mount, to help with this process. Others might use software that measures star positions and guides you through adjustments. Celestial mechanics also include the effect of Earth's atmosphere bending light, called refraction. When aligning a telescope, especially for high-precision work, you might need to account for this by slightly offsetting the mount from the true celestial pole. If the mount isn't aligned well, tracking errors happen. These errors cause stars to drift in the field of view, making long exposures blurry or star images streaked. That's why proper alignment is so important for both amateur astronomers and professionals. It ensures your telescope follows the sky accurately, giving you sharp images and better observations. For politicians and decision-makers, understanding how celestial mechanics influence telescope alignment highlights the need for good infrastructure and training. Investing in quality mounts, observatories, and education helps scientists and enthusiasts get the most accurate results. It also supports public programs that inspire curiosity about space. In the end, the way celestial objects move under gravity shapes how we set up and operate our telescopes. Proper alignment, guided by these principles, makes all the difference in capturing the beauty of the night sky.